Yes, welcome back. And we are still moving on with hydrocarbons, which I've said are compounds made up of carbon and hydrogen. And now we concluded that there are two classes: alkanes, alkenes, alkynes. And they have a general formula. Not that they have a general formula, but the first one that we are dealing with here is alkanes. Alkanes have a general formula of Cn H2n plus 2. We have given examples where n is equal to 1, where n is equal to 2, and where n is equal to 3. So, in this part we are going to continue by looking deeper into alkanes. Now, moving back to our screen, alkanes can be represented using, alkanes can be represented in two different ways. One, they can be represented by use of molecular formula. So you can use a molecular formula. And two, you can represent alkanes by drawing their structural formula. So we are talking about molecular formulae and structural formulae of alkanes. So what is this molecular formula? Molecular formula is a formula that shows the identity and the number of atoms present in a molecule. The identity and the number of carbon atoms, the number of atoms present in a molecule. Like when we talk of H2O, this is a molecular formula of water. What does it show? It shows the identity of the atoms. Like it is telling us that in a water molecule, we have hydrogen and oxygen. That's one. Two, it is showing us the number that in a molecule of water, we have 2 hydrogen and 1 oxygen atom. That is a molecular formula. So in representing alkanes, we can represent alkanes using their molecular formulae. We can represent alkanes using their molecular formula. This one shows that this alkane is made up of carbon and hydrogen. 1 carbon atom, 4 hydrogen atoms. This one is made up of carbon and hydrogen, the identity. But what are the numbers? Now, we have 4 carbon atoms and then 10 hydrogen atoms in this one. That is a molecular formula showing the identity and the number of the atoms present in a molecule. And then alkanes can also be represented by use of structural formulae. Now, a structural formula is a formula that shows the arrangement of atoms of each element making a compound. The arrangement of atoms of each element making a compound. You must now come in and indicate the bonding. How are the atoms bonded in that compound? So when we talk of the structural formula, we're talking about structure. Like I was using water. This is a molecular formula of water. But you find that in water, there is a covalent bond between hydrogen and oxygen and the other hydrogen and oxygen. So this is a structural formula of water showing how the atoms are bonded. We can apply that in these organic compounds that we call alkanes. Like when we draw CH4, we can decide that this compound, instead of representing it using a molecular formula, we represent it using a structural formula. So what are we going to do? We are going to write one carbon and one carbon. Carbon is 2,4. Remember we said that each carbon atom can form a maximum of 4 bonds because we have 2, 4. So this is carbon atoms. It can form a bond with this electron. It can share this electron, share that one. So how many bonds? 4. So this one can form a bond there, there, and there, another there. How many bonds? Those are 4. So we can have hydrogen here, the second hydrogen there, the third, and then the fourth. So if you look at the two formulae, then this one represents the molecular formula, showing just the number and the identity. But now this one, as we have gone further to show the bonding of the atoms of each element making up this hydrocarbon. So that is an example of a structural formula. We can also draw a structural formula of C2H6. How? We simply have 1, 2. Those are 2 carbon atoms. Then we indicate the bond between them because we are talking of saturated organic compounds. Compounds made up of carbon-carbon single bond. So we join the 2 using a single bond. Then each carbon must form 4 bonds. So we have 1 bond for this carbon, the second bond, the third bond, the fourth bond. First bond, second bond, third bond, fourth bond. Then we fill in with hydrogen. The first hydrogen, the second hydrogen, the fourth hydrogen, the fifth hydrogen, the sixth hydrogen. Right. 1, 2, 3, 4, 5, 6, yeah, the sixth hydrogen. So we have a structural formula of this hydrocarbon showing the bonding, Now, let us focus on the screen. Let us focus on the screen. Because on this screen, I have given a table, and this table we have N. N means the number of carbon atoms. Then we have the name of the hydrocarbon, the general or molecular formula, the structural formula, condensed structural formula, and then like that. So, let me help you understand the table. So in the table, we have I'm just going to do the first part so that you can understand. So in the first one, N is equal to 1. So this is N, is 1. And the molecular formula is CnH2n plus 2. Then we come up with the name. So, or let me have the name here. Then CnH2n plus 2. Like that. So now, where N is 1, we call that alkane methane. Methane. And when we substitute N is equal to 1 here, we get CH4. The structural formula, open structural formula, will be the open structural formula, that is the open structure. Open structure will be 1 carbon with 4 hydrogen like this. The condensed condensed structure will be CH4. So that is our first alkane. The second alkane has 2 carbon atoms. We call it ethane. Ethane. So ethane, if you substitute 2 here, you get C2H6. So we have 2 carbon atoms. Like that. That is the open structure. Then here, it is very simple. We will write the first carbon, 1, 2, 3. So we put 3. The second carbon, we write 1, 2, 3. Then we put 3. So that is our, then the third one, before we conclude, propane. Propane, if you substitute 3 in the general formula, you get C3H8. Then you simply write 1, 2, 3. 3 carbon atoms. You join them with single bond because it is saturated. And then each carbon 4 bonds. So each carbon must have 4 bonds. Like that, like that, like that. Then you bring CH3. The first carbon has 3 hydrogen. The second carbon has 2 hydrogen. And the last carbon has 3 hydrogen. So that is how we come up with structural molecular formula, structural open structural formula, and then the condensed structural formula. That one brings us to the end of our class today. Let us meet next time and continue with this. We'll meet in the Google Classroom for more explanation. Thank you for listening and keep safe.